Okay, let's learn some Elasticsearch basics. The way that we're going to do that is by submitting requests to an Elasticsearch cluster using this Swagger UI page. So I've written a open API specification for the core Elasticsearch endpoints. So that's going to make it easy for us to just use this page to basically learn all the basics of that. You do need an Elasticsearch instance to run these requests against, and on my blog there's a sort of a rundown of how to set up an environment. So one is obviously a cloud instance of Elasticsearch, which is should be a snap. So there's lots of people that provide that. I'd recommend this Bonsai organization. I think it's part of IBM. So there's some nice steps here about how to set up a test instance with Bonsai. So don't need a credit card, and CORS is enabled by default. So we need CORS to be able to use our Swagger page. So if you do go with the Elastic Cloud setup option, you do need to enable CORS, and there's instructions for you in that section. Alternatively, you can run Elasticsearch locally on your PC. Just need to have Docker installed, so you can do that yourself by providing some instructions using Docker and Docker Compose. So if you go to that GitHub repo, you can set it up. So however you do it, running through one of those two setups, either local Elasticsearch cluster or a cloud provider, if you run through those steps, you'll end up on a page like this. And this is available online. So if you have another Elasticsearch cluster already, you can pretty much just go straight here. Then when you go to this page initially, it'll ask you for the URL of Elasticsearch cluster. So this is the one that I'm using from Elastic Cloud. So I type that in, and then I need to go and authorize my requests. So this is basic authorization authentication. So type in Elastic and then the password and hit authorize. So now I should be able to see if I can connect to the Elasticsearch cluster. All of the endpoints have sample responses, so you can get a really good feel. Even if you don't have Elasticsearch cluster in the background, you get a really good feel about what the responses would be like for each one of the requests. But obviously it's much better if you can run the request yourselves and make changes and then see those changes reflected. So I guess just again stepping through how the the Swagger page works. Basically using this URL here, it'll submit a request to that URL with that path, and any parameters we can change those here. So assuming we've done everything right, we hit try now and hit execute. So that's run that request. So basically that's the request that's run. That URL, it's got the password that we provided, and it's got a response, which is awesome. My cluster's green, yay! And we're getting a response, which is even better. So this endpoint cluster health tells us that the number of nodes in the cluster, number of data nodes, if the status is green, how many shards we have. Okay, so let's talk about the concept of shards. So an index is just like a table in Elasticsearch, and a shard is a fragment or part of an index. And indexes are sharded across multiple nodes for speed in searching, but also from resiliency. So that's the concept of a shard, and so when we're talking about shards, we're talking about parts of indexes that have been distributed through the cluster for performance and resiliency. So that's all looking good. So let's get into the detail. So as I said, there's these indexes within Elasticsearch, and those indexes, like tables, store our data. When the data's indexed into those indexes, it's indexed in a certain way, and then that makes it easier for us to extract it out, but we can change that configuration as well. So let's just try out here and see. So this is the _cat indexes endpoint. So cat stands for compact and aligned text. So there's lots of cat indexes within Elasticsearch, which will be really useful as you go along. But they do also have so the cat part, if you just use the column view, so cat indexes, so V is basically to show headings, and format is the column format. You'll see that so that we've got two indexes here already. So one's called country and one's called test, and these all other ones start with dot, like system or internal indexes. So that's like a nice view of the information. But yeah, if you do say JSON format and execute that, so basically again, so let's change that to format execute, you get a nice machine processable response if you need it. So that's the list indexes, endpoints, so underscore cat indexes. Let's create an index. So create an index, we'll call it test2. And when we're creating indexes, so that'll submit a request. So it'll substitute test2 into the path. So it'll do a put request to that URL with that index name in the path. And we can specify the configuration. So for example, the number of replicas. So how many replicas a shard has, and how many shards an index should be broken down into. The type of compression that we should use for the source documents when they're saved into onto the nodes, and the refresh interval, which determines how quickly we can see a result after it's been indexed. And so this is a basic configuration here. So let's just use the basic configuration. So that should have created our test2 index successfully. So we've got an acknowledgement, it's all good. So now if we scroll up here and hit execute on the list indexes endpoint, we'll see that test2 is now within our cluster. Our cluster is still green, which is great. We can get the details for that particular index by doing a GET request for that that index in the path. So it looks like this: the URL, the index, and GET request there. And here we can see that there's aliases, mappings, and settings for our index. So aliases are like a view from an SQL land. They don't hold any data, they just can point at one or more indexes or a subset of an individual index. So they can have some filtering as well, so just like views in SQL. So mappings define the types of each field and how those fields are indexed. And the settings are the things that we set some of them before about replication, number of shards, those kinds of things. You can also set where the data should be located. So what tier, or it needs to be on hot storage or cold storage, those kinds of things. So that's getting an index. We can also update the settings for an index. So we can change so for example, our test2 index, we can set the replication to 3 and submit that. And then I'll get a response saying, yeah, it's been acknowledged. And I wonder if anybody can guess what that will mean. But now if we go into look at our indexes, we're expecting to see one of them's now yellow, because what we've asked for is replication of those shards, replication of extra 3 replicas. However, we only have 2 data nodes. So therefore, the Elasticsearch can't meet the required level of redundancy on the 2 nodes it has. So that index now goes to yellow. So that changes the one index to yellow, and then if we look up here, now our cluster health will also have changed to yellow, so it sort of rolls up to the next level as well. So I just wanted to touch on, so why would you want to change the index settings? So the example is that you've got a new index, you're building it, you may be testing it, so you want to be able to create it quickly, so you'd set the number of replicas and the refresh interval and compression and various bits and pieces, and I guess the nodes that it's processed on to give you the best performance. But then after that index is built and it's in production and it's stable, you may then want to change the index settings to make it more resilient and faster to perform from a querying perspective versus an indexing perspective. So they're the sort of reasons why you think about changing index settings after index has been created. So the delete endpoint for indexes under index management. So we can go, can do star. So we just do test star. So that will get rid of all the indexes that have that. You just get it acknowledged true. So you don't really know what happens there. It doesn't say which indexes were deleted, but that deletes all the data for that index, and it supports wildcards. So there is another index that I was playing around with before, which is country, so I'll get rid of that as well. So that's sort of cleaning up the mess. So yeah, you saw that you can use wildcards within that request, and if you do use wildcards, you just got to be careful to make sure you don't delete something you shouldn't. So that's index management, pretty straightforward. Now we can jump on to creating documents. So if you don't have an index already and you send a request to Elasticsearch to create a document and specify the index name in that request, it will automatically create the index with the default configuration. So different scenario. So if you have an external system like a system of source of truth, then yeah, often you'll have an ID in that system. So when you provide the document to Elasticsearch, you can use that ID to uniquely identify that document. And so if there's updates that come through afterwards, you can use that ID to replace the existing document. Alternatively, for logs and other systems where you may not have that unique ID for that record, Elasticsearch can allocate an ID for you. So let's just do the simple example where you've got an ID. So I'm using ID 1, and so I have some sample documents here, as I mentioned. And also, as I mentioned, that I've included in the schema example responses for all requests. So you'll see what we're expecting to see here is that there's a created record and a version 1 of that created. So if I hit the execute button, I expect that's what I'll see. Yep, 1 created, Shards 2, all good. So that's created our first document with a document ID of 1. Possibly in the future we may want to change that, so we can change some details here and then submit it again. And what that will do will be replacing the previous document that we had. So you can see that now it's version 2, and the result of that request is an updated rather than a created response. So that's when you supply the ID as part of the document creation request. Alternatively, you can let Elasticsearch allocate a ID. So again, we can just select some other sample documents here. So we hit submit, and it's going through and it will add those documents to Elasticsearch and allocate an ID. So the sample documents that we've added, so there's 4 documents that we've added to Elasticsearch. So that's how you create documents in Elasticsearch. So with IDs and without IDs, yeah, pretty straightforward. Now let's go retrieve some of those documents. So this endpoint's a get endpoint. So again, we have to pretty much always have to specify index to identify what we want to get out of Elasticsearch. The format here is index_doc/ the ID that you want to extract. So we're expecting something like this, and we hit the button, and that's exactly what we got. It's that second version, as you'll see. So you'll see that there's this various metadata about the request, and then the actual source document that we submitted. You can see it's the second version of the document, which is that version thing. And you can also see which index it's coming from. So you can run queries and searches across multiple indexes, and you get different metadata, obviously. So that's getting one document by ID. So the next one is a post request, which is going to give us. So we can just send a request to the index name _search, and with no body. To provide the index name, so it's just told me to do that, so I've done that. And then, as expected, there's those 4 documents that we added. So one where we provided the ID, and then 3 where the ID was provided by the Elasticsearch. So this search endpoint, it's like where all the magic, all the power of Elasticsearch comes together. You can just do queries, much more powerful than in SQL. So there are some examples that have been set up here. So this is what a range query looks like, where a particular field is greater than 1 or whatever it may be. You can do match queries, which basically like the sort of free texty kind of search queries where you specify particular fields, and there's lots of parameters to that. And the final one is query string, which is similar to the address bar in Kibana. So more of like a general search across the board. So yeah, so let's just run this one. Expect to get one document back, which is the Afghanistan document that you added. Yep, so you can see the response here. Yeah, various metadata about the request, how long it took, how many shards it hit, if it timed out, and then there's a hits section, which has the total number of hits. Once there's over 10,000 hits, it stops counting. There's ways to make it keep counting, but yeah, that's sort of that next level in the hits section, as well as the score. And then we have the hits list. So basically it goes hits.hits, and there's a list of documents that match that particular search request. So yeah, as you can see, so there is ways to do custom scoring and adjust the scoring of the individual hits and sorting of those as well. But yeah, that's yeah. So searching requires its own video, I'm sure, and maybe I'll get to that if anybody wants that. But yeah, that's how you retrieve documents out of Elasticsearch using the post to the _search endpoint. So it's retrieving documents. So updating documents, you can, so yeah, so I think as I mentioned above, if you want to just replace an existing document with a full document, it's just submit it with the ID of the document that exists in the data in the Elasticsearch already, and it will replace it. So that's happy days. You can make some updates to existing documents. So for example, adding a new field. So let's add a new field to the Afghanistan document. So click accept. So it's added that new field. So you can remove a field. This is the syntax that you use to identify the source. As you saw that there's the _source to identify the actual document that was submitted. So you can add lists to documents, which is again just using this syntax to say, add, so that in the doc, add this new field list. And you can also add values using, also you can have much more complicated logic using this painless language, which I understand is similar to the Java string processing language, or subset of a Java to do that. So in this example, we've said, if that new list contains this number here, then, so if it doesn't contain 10 million, then add it to the list, else do nothing else. So this is like an operation of none. So we can execute that. So we expect to be successful, and it did update the document. So now if we go back and retrieve that one document, we'll be able to see that, so it got the new field added, it had the new list added, and it added the 10 million figure to that list. So we can update individual documents with new fields or updates to fields. So that's totally supported. And we can do those similar types of updates based off a query. So this query is the same as that search query or that search payload. So if we just do country, as you'll see, that query request looks like that, which is what we saw when we did retrieving documents using search, and that script is a script similar to the script that we had when we were updating documents for a particular ID. So it's basically for all documents that match this criteria, go and add a new bulk added field with a value of update by query. So I guess the interesting part of this is that you can change this parameter wait for completion. So wait for completion true will actually get a response, and it will just hang there until all the updates are completed. If you select false, then it will give you a task ID back, and then you can manage that task ID separately. So basically you can throttle it or cancel it later, those kinds of things. So let's hit execute there. And it's given us that task ID, so it's off in the background making that update to add this new bulk added field. I'm sure if we scroll up here and retrieve that document again, we'll see that bulk added field. Bulk added field, update by query, added to the document. So that's all working well. Now we're into deletes. So we just go down to delete. But delete's pretty much as you'd expect. Country, ID 1, hit execute. Yep, it was deleted, so it no longer exists in the index. We execute again, it says not found, as expected. So all looking good. We can then also do a delete by query, again similar to a search when we're retrieving documents, but this time it doesn't actually apply any updates, it just deletes the whole document. So for example, we can say country, wait for completion true, and I think it was island, there was an island there. So we hit execute. So it didn't actually update anything, but yeah, that query did run, so it submitted that request. It said anything that matches this query, go and delete it, and wait for completion equals true, but didn't find anything that needed to get deleted, but the concept was done there. So yeah, again, they're highlighting that that's the Swagger page includes sort of example responses. So yeah, you don't need to get the Elasticsearch working in the back end, but you can if you can, it's much better. So I guess that's my summary of the basic Elasticsearch endpoint functionality. Yeah, comments, questions, let me know. Yeah, thinking about doing one for search with lots of different search types as another example. But yeah, please give me all the feedback you got. Thanks guys, bye.